Hi folks, this is Nachiket signing in for today's topic raw materials field tests based on physical site conditions. Uh, Remember, we're doing this presentation for low risk building and building built from scratch, right? Under the prime phase, that is mobilization works. So let's quickly dive into our slides. Remember, we're doing this test on various raw materials, and they are as follows: like cement, thermomechanical treatment treated steel, then fine and coarse aggregates, red and fly ash bricks. Okay, so herein you need to understand one thing: there are many field tests which are based on IS codes, and some are basic by basic understanding. So as per the basic civil engineering knowledge, you need to understand that the test part will be covered in a different phase that will be conducted on field. Okay, so that will be a practical example for you, but here in this slides we'll be just understanding the basics at what are the tests that are being done. Okay, so not going deep inside, right? So here it is, the basic test for cement. Here there is no scientific test or any kind of IS code provisioning test is not here, but there are a lot many out there. So the first part is you need to check the packaging details of the cement bag. What is the whether there is any ISI mark or not. Then again, what is the manufacturing date, time of expiry. A cement bag can maximum go to 3 months. So from the date of manufacturing, you can understand within you have to just consume that within 3 months, right? Then next is the color of cement. It should be greenish gray. Then you need to find whether there is any lumps or not. Then you need to also find the texture of the cement. If the texture is too gritty, then it is not okay, right? Means kind of organic materials or inorganic materials are out there, so it is also not good. Then the temperature. When you thrusted your hand inside a bag of cement, you should feel cool. If you don't feel it, then something is not okay, or there is a heat uh, that is continuously getting in, and the cement is trying to set out. Okay, and also the quality of the cement deteriorates accordingly. So you need to feel cool when you thrust your hand inside a cement bag. Then the finger rub test. You need to just rub, take a certain small amount of cement and rub it in your hand, in your fingers. You can feel a very polished approach, and it's very powdery and very polished. If you don't feel it, then something is not okay. Then seventh is the most important, that is bucket flow test. Take handful of cement with you. Take a bucket full of water, and just throw it into the bucket full of water. And if it floats for some time, then it settles down slowly. Then it's good. If it just settles down very quickly, then I think there is lumps inside, and continuous due to heat of hydration, the cement is deteriorating, right? Then the next and most important part is TMT steel. We are basically conducting three tests for steel. That is mass per meter run, then bend test, then rebend test. Remember, the bend test, rebend test are as per the IS code provisions. That is IS 1786 has briefly explained this test. But let's understand in a very simple manner. The first part is that mass per meter run. You need to simply uh, cut a 1 meter of length of any kind of dia and just weight it. And as per this chart that has been given here, this chart, you need to find out the weight of per meter uh, TMT rod. And if the weight is less than this, then remember something is not okay. You need to complain to the procurement team, and they will take needful action. Okay. Then second is uh, a simple bend TMT test. Here you need to understand that one a particular rod, the 1 meter rod, it is just bent to 90 degree. Then in the opposite side, you just need to find out whether there is a rupture or crack out there. If it is there, then it is completely faulty, and you need to replace the steel. Then again, there is another test, that is rebend TMT test. Here what you can do is uh, just bend it to 135 degree. Just bend the rod to 135 degree, and just put the rod inside a hot boiling water, then wait for 30 minutes to cool down, then take it and rebend it to 157.5 degree again. You can see here it's been uh, rebent to 157.5 degree. Then just see the back of the rod which has been in tension, the outer part, here in the outer part. If there is a rupture or crack, then the steel TMT is faulty. If it is not, then you can use it for your purpose. So these are very simple tests that can be done over in site. Okay. The next test we are going to conduct for fine aggregate. It is very quite important as well. So number one is silt content test. Here you can see we are using a 300 ml barrel out here. Then here what you do is just take a particular weight of sand sample, put it inside the barrel, then put water inside. Then you see what is the settlement ratio. The silt will be above it and the sand will just be deposited in the down, and from here you can just measure the particular amount of silt out here, and then find out, then convert it into percentage, right? So you will find that the percentage should not exceed 5%. If it is exceeding 5%, then reject the sand immediately. The next part is the particle size distribution. Remember, for plaster you need different kind of sand, different micron of sand. Then for normal concrete you need different kind of sand, different sizes of sand. So this is very quite difficult to analyze. So what IS code has given a provision is of a distribution passing percentage of sand. So here are various types of sieve sizes. You can see from 10 mm to 150 microns. 10 mm, obviously every sand is going to pass that particular test, that particular sieve. Then the 4.75 mm sieve, then 2.36, 1.18, 600, 300, 150. So based on the passing, you just need to put this soil sand sample in the top. Just need to arrange in a pattern, then just put it, shake it properly. Then after shaking for 2 minutes, what you will find is the sand will be graded itself. So after just taking the weight of various sieves, you can find out the kind of gradation, and based on that you can find out the fineness modulus of the sand. So for coarse aggregate, there is a particular provision, then again all are provision. So all these tests will be done again, but remember this is the test that is done on site. Then the third is organic impurities test. It is also quite important. In organic impurities test, you need to conduct, you need to see a lot of things, that whether there is any seashell or kind of clay materials out in there. If it is there, then reject that particular sand sample. Okay. So it is quite important to understand this. Then fourth is bulking of sand. Sand has this property basically. When it is dry, it has less volume. Once it is getting wet, it will have a different volume. So understanding that particular pattern of fine aggregate, what needs to be done is you need to measure that, right? So based on that measurement, what you'll find is if there is a 2% of moisture content, then there will be increase of volume of 15 cubic feet, right? So there are a lot of tables out in there, so that will help you to understand this particular test, how it is done. So it is quite important to understand this bulking of sand part, because this is also necessary while calculating the volume of the concrete, because sand is massively used in concrete, right? So these things needs to be understood. The next is that field test for coarse aggregates. There are basic two types. One is sampling, that is includes your color, shape and sieve analysis. Color is quite important. If it is white color, then it's not good. If it is black gray color, then it is good quantity. So the color is a differentiation part, and you need to decide on basis of color, and it is the first hand look of the coarse aggregate that will help you to decide. Okay, take a soil sample, just segregate it and find out what is the white one, just segregate it, and what are the black ones, segregate it, just weight it. So the percentage of black should be more and white should be less. If the white is more or equal also, then reject that particular uh, part. Then shape should be round, it should be uniform, it should not be flaky. Okay, it should not be flaky, it should be uniform in every direction, so it should pass that particular shape test, right? Also check the sample, take some sample with you, just find out how many are flaky type, means elongated type, and how many are rounded uniform shape. Okay, so based on that gradation you can also make the test. Then sieve analysis, this is the best way possible to check the gradation of coarse aggregate, right? The way we are doing in sand, the same way we are doing in aggregate, but here the sieve designation will change. It will start from 80 to 2.36 mm, right? So this is what the sieve analysis test is done. More on this will be given on the field test while doing it practically, right, on your side. Then the next part is the surface moisture content and absorption. Basically, pan fry method is basically used. What is done is, in a pan we just or in a kind of, also you can put it inside your oven. Inside a oven you can just fry it, or you can just heat it so that all the moisture content are gone. Before that, previously you need to weight that sample. If it is, suppose you're taking 2 kg or 3 kgs, then after this heat part, what is the weight? So if there is a massive change, then something is dangerous, because coarse aggregate are not porous, they are very dense. But if they are porous, it means the water has been percolated inside it, and after this moisture test, you'll understand that whether the coarse aggregate is good or bad. Okay, so even ice code has provision for this as well, but it is quite difficult to do on the site. So best is to understand that the sampling test is the best option for field test, right, for coarse aggregate. The next part is the for red bricks. Field test for red bricks are water absorption test. Same way, because bricks are very porous, they absorb water, but not more than 70%, right? So the same way, you need to just check a dry brick. Then after you need to check the weight of the dry brick. Then after means putting inside a bucket of water, just check the brick weight. Okay, if it is very porous, then it is not good for construction, so you need to reject that immediately. Then visual inspection. In visual inspection, what you can see is, you can see a lot of organic materials are also used sometimes. So organic material are not good. It will what will happen is, after some time, it will give birth to fungal side, and it will also help in vegetation as well in your house. So it is not good for the construction, right? So always visually inspect the brick before taking it. Then efflorescence, you need to understand that it should be red color, and if it is more whitish, then it is not good, because certain kind of efflorescence chemical reaction has been occurred, and the brick quality is deteriorating, right? Then fourth part is dimension. This is quite important, and is also a very important test. This field test will be explained in more detail in the last in our field visit tests. Okay, so here what is happening is, you need to take 20 bricks at a time. You need to arrange it simultaneously, and weight, and you need to check the dimension of the entire brick size, and check it in mm. The standard brick size, like after arranging 20 bricks accordingly, what should be the size, practical size and theoretical size, it should match. If there is a lot of difference, then reject that bricks immediately, and it should be of proper size and shape as discussed. Okay, then next is hardness test. Same way, you need to see how much means dense, how much dense it is. And in case of soundness test, while you are just striking two bricks with each other, you will find a metal sound. You can hear the metal sound out there. If it is the clanking metal sound is very good, then the cement or the red bricks quantity or the quality is good. Then in case of structure, the same thing. If it is broken, if it is deformed, you should reject it. Okay, so next in the case is fly ash bricks. Fly ash bricks, same, all the tests are done. Only one thing that is very important is, in case of fly ash bricks, which is very important, is you will find that the fly ash bricks are not as per the CPWD machinery guidelines. Means fly ash bricks undergoes uh, pressing of a huge quantity of load out there. After that pressing only, you get a good quality of fly ash bricks and a very unique shape fly ash bricks. So CPWD has guidelines for that. If it is hand molded, then reject it immediately. Go have a visit to the fly ash bricks factory where it is done. If they're using proper CPWD guideline machinery, then only purchase fly ash bricks from them. Otherwise, reject it. Okay. So thank you. See you in the next video. Site layout.